This video will walk through the LCD method on some problems from PZ131. So let's start with A. The common denominator in A would be 9x. That would be my LCD. So to use the LCD method, I would bracket the entire equation and I would multiply each term by that denominator over 1. And mentally, the way you can think about this, and I'll put my work down here, you can think of this as, first up, I'm going to multiply 9x over 1 by 1/9. And then what would remain would be the missing factor of x multiplied by the current numerator, or just 1. And then I would multiply that same fraction by 1 over x. And in this particular case, the x's would then divide away, and I would be left with 9 times 1, the missing factor times the current numerator. And then finally, I would do the same thing on 4 over 9. The 9's would divide away from the problem, and I would be left with the 4 from the numerator and the missing factor of x. And I would turn this into a nice pre-algebra problem. Let's do the same process on B, problem B. So here my common denominator would be the 5 times the 2 and the x, all 3. My 10 would be 10x. So I would bracket the entire problem, and I would multiply each term by 10x over 1. And I'll put the outcome down here. And you can finish these problems on your own. I'm just sharing with you the new piece. So first up, I would have 10x over 1 times 2 over 5. 10 divided by 5 is 2, leaving you with 2 in the x, times the 2 that's already there. So that would leave me with 4x. And then I would have 10x over 1 times 1 over x. X's would divide away, and I would be left with 1 times 10, or just simply 10. And then at the last, I would have 10x over 1 times 1/2. 10 divided by 2 is 5, and then x times 1, so that would be setting this equal to 5x. And I'm confident that you all can handle it from there. Let's look at some of the more complicated problems on the other side. So let's look at the problems over here, a little bit harder. So first of all, we'll start with something like G. The easiest way to do these is to look at the current problem and factor that denominator. So this is really x over 2 times x plus 3. And then that's going to be minus 1 over x plus 3, and this equals 1. So when I look at the denominators, and I look at each denominator in its most factored form, in a completely factored form, then it makes it easy to identify the least common denominator. So in this particular problem, the LCD would be 2 times x plus 3. Now to use the LCD method on this, if I have 2 times x plus 3 over 1, and I do the same process that I just did on in the other column, it's easy to see that in G, when I multiply the first, what remains is just going to be that numerator of x, because this particular ratio already had the common denominator. And then moving on across, well, I can see that x minus 3, or x plus 3 rather, is already a factor here. So if I were to multiply these, the x plus 3 binomials would divide away, and I would simply be left with 2 times 1. So that's going to be minus 2. And then the last step, well, since it is 1, I'm going to have to pick up all of the pieces of that denominator. So I'm just going to go ahead and say that that's going to be set equal to 2x plus 6. And in this particular problem, I also need to list my excluded values, or values that would create an undefined expression, division by 0. So I look at my denominators, and I decide that x is not allowed to equal -3. If x equals -3, then I have undefined expressions. So let's go back and solve this. And let's see, if I'm going to subtract 6 from both sides, and x is -8. X is -8, x is not allowed to equal -3, so I'm cleared on that one. Let's go on and look at the second problem. Okay, in H, the common denominator is going to be m plus, well, I could do this with cross multiplication, but there's another interesting feature with this problem. So let's just do it with cross multiplication, but first let's list the excluded values. x is not allowed to equal positive or negative 5, because if I were to factor this, I would see that it's m plus 5 or times m minus 5. So if I perform cross multiplication on h, then I end up with this. M squared minus 25 being set equal to 2 times m plus 5. So if I clean this up, add 2m to both sides, subtract 10, and then I factor this. And I see that x equals negative 7 or x equals positive 5. Well, I have a problem right here with x equaling positive 5 because I've already said that x is not allowed to equal positive 5. So this can't be a solution. So the only solution to this particular problem is x equaling negative 7. So when you're dealing with rational equations and you have excluded values, you always need to compare your excluded values to your final solutions to see if one of the solutions is actually a value that makes the original problem undefined. And if you have that happen, then that particular number is not allowed to be in the solution set. Let's do another one. Let's look at letter I. So here my common denominator is going to be y plus 3 times y minus 3. So here's my LCD. And that means that my two excluded values are positive and negative 3. So I'm going to go ahead and use the LCD method on this problem. So I'm going to multiply by y plus 3, y minus 3 over 1. And as I roll across, I see that I've already got a y plus 3 factor in the first expression, so the 1 needs to be multiplied by y minus 3. And then I look at the second expression. Well, it already has the factor of y minus 3, so I'm just going to pick up y plus 3, but I need to multiply that by the numerator that was sitting there, by the 7. And then the last expression already had the common denominator, so all that remains is the numerator in the last expression. So now let's carry on and clean this up. And let's see, so that gives me negative 6y's, and 21 minus 2 is 19, but I add 3 to that, and I get 22. So with this problem, I end up with y equaling 22 over negative 6, which is negative 11/3. That's my value of x. I compare that to my excluded value set. I see that I have no overlap, so x equaling negative 11/3 is my final answer. And I think that's probably sufficient to get you through the rest of these problems. Let's just look at a few of these. They're all pretty much the same. Look at the denominator in its factored form, and then it makes it easy to identify what the LCD is. So in J, this denominator would be 2 times x minus 2, which makes it easy to see that that is the LCD. And then in a problem like K, I have x times x minus 1, which ends up becoming the LCD in this problem. And it just makes it easy to see that when you multiply by the common denominator over 1, it's easy for you to see which factors need to be picked up as you go along with the process. And then in L, your common denominator would be n times n plus 5. And don't forget to list your excluded values and then compare the excluded values to your solution set to make sure that you have no discrepancy.